So welcome to Flower Monthly for September. Um, Another great community event is planned for you. I'm going to run through first the agenda and we can see what we have in store. Thank you all for joining us. So my name is Nicholas Lane and the agenda is we're starting off with a few flower updates. Um, Primarily about a number of events that have happened recently where Flower has gone out into the community. We also wanted to highlight a few of the new releases in the code base for you all. Um, and then I think we're going to, after the Flower update has taken place, we're going to go with Lorenzo Carnavali from the University of Messina. He has got a really interesting piece of research to show you, um, where he's taken the Ross framework um, and used it in a federated learning context. And so I'm really interested to see the type of work he's done and how this relates to collaborative intelligence in sustainable cities. You also would have recognized Lorenzo from a few other Flower events such as the Flower AI Summit not that long ago, and and other events too. Welcome back, Lorenzo. Um, we also have with us uh, Samania Mohammad Ali from the RISE Research Institutes of Sweden. She is going to be presenting in cluster. So that's the use of scalable functional encryption in federated learning. This was work, I believe, that was done along with Velasilos uh, Tours Valles from Eindhoven University of Technology. Um, and so I believe she's had a few technical difficulties, but I think we're almost underway here. Um, and so with that, let's move on to the flower updates. The Looking back in the past month, there's a lot been going on. But I think still the highlight has been the release of Flower 1.11. That's the most recent release that we pushed out. It has a ton of new functionality, including really important contributions from the community, but then also some important features that have been requested and worked on by members of Flower Labs for quite a long time. And so here really is just uh, a series of highlights. Um, if you want to see all of the sort of laundry list of improvements, bug fixes, and new features, do check out Flower Discuss, where we have a pretty comprehensive post on there. Do give it a try. But if I'm going to just run through four of the most exciting aspects, I'd highlight first um, automatic dynamic code updates. What I mean by automatic, I'm talking about auto delivery, whereby you can take a Flower app bundle, and deliver this to a Superlink or a super node as needed. So when you have some change to the code, you want to push it out to your clients. This is a mechanism that you can use, and this is going to be quite a powerful tool, we think, for many users of Flower. Um, Second, we have introduced the ability to have isolated client app execution, where client apps can now run, if needed, within isolated containers. And so you can have more than one operating at once, and there is a minimal interference between them. So there's definitely, if you're thinking of running more than one application within a federated infrastructure, that's super useful. And then finally, improved enterprise Docker support. So you can imagine situations where you want to perhaps deploy Flower in enterprise. We've got some new all-in-one Docker images for you to use. And then there's a new Docker Compose capability that enables you to sort of easily start to push out a deployment using the full Flower deployment engine. Um, so that's those are three main ones I want to mention for you. I guess the final one I just will go over. Um, there is a variety of new and improved Flower templates. So if you want to use Flower and get going really fast, you can use our command line interface to use like commands such as Flower new and Flower run um, that can automatically set up for you a project that you can then customize as you need it. And so these are ways that we're making it even simpler and lowering that friction to deploying your first federation. So there you go. Flower 1.11 available today, and it's been available now for a few weeks. Next, we're really cognizant of building great environments for our community to get together, to exchange ideas, to interact. Um, and two opportunities I want to highlight that I think many of you are already using one of these, at least perhaps both. We have Flower Slack. We were looking at the ways that people were using Flower Slack, and we realized that a lot of folks out there um, we're using it to search for news items related to federated learning. There are requests and exchanging of papers, research papers, and even folks who are looking for various kinds of jobs of all kinds. So conventional jobs in terms of employment, but also learning opportunities in the form of master's projects, master's programs, PhD programs to apply to. Um, and so what we've started to do is we've introduced a few channels on our Slack dedicated to these purposes, and we're going to try to reasonably frequently update them with content for you. But you should also be feel free to join these channels and share opportunities, news items, exciting papers that you think are valuable with each other. So those channels are up and running now for quite a while. I saw, for example, yesterday there was a brand new job posting that looked very interesting, posted by a member of the Flower community. So that's great stuff as we to get together to grow um, the federated ecosystem even further. Flower Discuss has been around now for a few months. We're using that vehicle as a way to um, provide detailed answers for some of the most frequently asked questions where these answers are going to persist. And so with Slack, it can be quite hard to find and follow threads particularly on very technical questions on how do you do X, or if you've got a problem, or if you're looking for a particular approach. Um, Scrolling through Slack channels and trying to piece together different threads to understand an answer isn't always the best way. And so while Slack is also a valuable way, valuable way that you can get feedback from members of Flower Labs or members of the community to answer your questions, we wanted to have a secondary, but also, very important channel in which we can provide persistent answers where it's very easy to follow a lengthy response, or you're able to post a quite a complex query, or um, whenever a query might have a lot of people who want to, frequently come back and refer to that information and share it with other folks. And so that's what Flower Discuss can offer you. If you haven't tried it out, please give it a try. We've already got some really great answers posted by members of the community or Flower Labs to frequently asked questions. So yeah, please take a look today. We want to highlight that for you in this update. When I think of events that are happening with Flower, we really have had a very busy past 30 days. Um, in assembling this slide, I really want to just try to briefly summarize some of the big things that have happened, but by no means this is not everything that's happened lately. Um, I was thinking just this week we had Daniel and Tanner in Sweden attending one of the bigger fog related research conferences, giving a keynote, telling folks about Flower and how they could use this within the domain of fog computing and other edge AI scenarios. we're also, all of us, very proud of the award that Mozilla gave Daniel in the entrepreneurs credit category for what they call the Rise 25 event. And Daniel gave a really great speech that you might have seen on our YouTube channel, where he was pointing out the sort of the importance of what we're all working towards together in terms of making collaborative AI a reality. And so really he was saying that this award is a function of everyone's efforts and the progress we've all made together in this direction. Um, the final event that I want to mention also happened quite recently. KDD is perhaps the largest data science conference in the world. It's one of the most prestigious. It happened to take place in Barcelona um, this year. And so we were invited to give a really detailed hands-on tutorial on how you can do federated learning with a lens on privacy preserving techniques. And four of our research scientists went out there. You can see in these pictures, there was Mohammed and Jan. We also had Pan and Javier, um, each providing their unique view and providing, technical details on how you can use Flower to very easily solve um, both research and real world challenges. Um, and so that was just a few weeks ago. And that is like a highlight reel of what's happened, Flower looking backwards. Um, What's really cool is that we have even more in store. And so you might have seen on social media this animation that Ruth put together. It's really cool. So I just thought it deserved its own little place here in the Flower update. And it's just cycling through a series of events that are happening within the next 2 weeks approximately. One of those events is actually happening right now. We have our Flower Monthly is listed at the front of this queue. And then we have a number of other events with organizations such as NVIDIA, Amity University, Amazon, Mydray. And so these are happening on singular or multiple days. If I just advance the slide, we can not have this animation go rotating in front of us as much, and we can just look at what's going on. These are all events that you're all very welcome to take to partake of. Just running through the dates, we have September 12th and September 19th, an introduction to federated learning and privacy preserving ML as a workshop. This is a sort of an experiment for us because we were approached by Amity University, Nodia in India, along with an organization called the CSSP Club. And so some really active students and professors approached us about running an online workshop where we would describe the key concepts and point to key hands-on tutorials on allowing people to get involved in federated and privacy preserving learning. So this is happening over two dates. Each date will go for 2 hours at each time. And those who participate and join in on the dedicated Slack channel, for example, where you can answer questions and get resources, those who complete the full course will get an e-certificate. Um, and so for those of you out there who are who basically have an organization that wants to see an event of this kind run, we're happy to work with you to spread the world of federated and privacy preserving and other related topics, differential privacy, um, distributed learning, decentralized methods, and so forth. We're happy to work with you to have similar events. So we're delighted to work in this case with Amity in the CSSP Club. Um, Mydray is an organization that provides trusted cloud environments, I guess you'd call them. They are certified um, under a variety of types of processes and trusted by a number of hospitals and organizations that have highly sensitive data. And so in those, very specific, highly sensitive data cases, we are working with Mydray to combine the software of Flower with the battle-tested, proven MyDray client cloud instances. And so then people in these organizations can use a combination of these two things to have very secure environments in which they can do um, federated learning, federated analytics in secure environments that have been certified by the appropriate authorities. So if that sounds like it's something you want to get involved with and use, join us on September 16th, where there'll be a workshop on this. Um, September 13th and 17th um, is Amazon and Flower working together. We've been working together for quite a long time to provide enterprise types of federated learning, in particular for um, financial institutions. And so at this event, you will have speakers from Flower and AWS Amazon talking about how you can easily stand up these enterprise style deployments using Amazon infrastructure. And so there are some companies that really prefer to use Amazon, and if the number of them out there have reached out to us to provide this type of information. Amazon also asked us if we can run these because they're getting so many queries from people wanting to build Flower-based systems. We thought it was time to run a workshop. And what's interesting about this workshop is that we're going to give one workshop in Chinese, one workshop in English, and one workshop will be scheduled um, around times that are compatible with Asia to handle all of the Asian-based organizations that we're getting requests from. And the other will be targeting North America and Europe to handle requests from those folks. Um, Finally, September 18th, we were invited by NVIDIA to talk at the NVIDIA Flare Day. And so we have Daniel will be presenting a talk on how you can actually run Flower projects within NVIDIA Flare components, because this has been something we've worked together with NVIDIA in terms of compatibility now for a number of months. We announced it at the Flower AI Summit, and this is us gradually delivering on this promised compatibility so that you can write your Flower apps, you can write your federated learning systems using Flower APIs, and that if you need to run them under either with Flower native support, or in some cases you might need to run it in NVIDIA Flare environments, you can do so. And this is a big step forward for compatibility and being able to build large federations that work together. Um, there are the details of these events, so the times and so forth, are available on our social media channels, our website, that's flower.ai. And so we hope that you can attend the ones that you think are appropriate for you. But we hope this really does accelerate adoption of federated learning even faster. So that is the Flower update um, for this month. Let me now hand over to Lorenzo. Lorenzo is an assistant professor at the University of Messina. We have, as I mentioned at the start of this event, he is a frequent contributor to Flower, so I'm delighted to have him back here. And I've always thought that there was a huge potential for federated learning and robotics to work together more closely. So I was delighted to see the work he's been working on. I think he told me about this work all the way back in March. And so I'm really interested to see how far it's gone. I haven't seen much work of this kind yet, so he's really blazing a trail in this direction that I hope others will follow. So, Lorenzo, thanks for joining us, and we're very excited to see what you have for us today.
Thank you, Nick, and all the community. Let me share the screen. I share just the window. Let's see. How can I do it? Window. Okay, let's share the entire screen. Maybe it's better. Can you see something? I think not, right?
Not yet.
is not stuck the button. The share button is stuck. You cannot do nothing.
Uh, do you think it's your end or do you, I'm just looking at the settings. I think we're fine.
In my on my site, I can try to leave and enter again.
Yeah, maybe do you want to do that?
Yeah,
We
let's
can,
second, sorry.
sure. Um,
And so in the meanwhile, hi, can you hear me?
yes, yes, I can hear you fine. So we're good.
Yeah,
Do you want to try sharing just to see if
yeah,
that's
yeah,
working
sure.
fine?
Because yeah, there are lots of like um so entire screen and preventing access. Your browser is preventing access to your screen. Oh, I think we had um,
So you might, yes, I think there's a setting involved there, but at least we've made progress. You can share your screen now. Oh, you can share your video. We can hear you. You can hear us. That's great.
but I think yeah, this is a problem. I can't install this client side the Zoom. I still work using this browser. I don't know. I had some problem with permission because the laptop that I'm using for from the like institute. So I think it's
I think
still
I think under settings, there's an option to enable the browser to share. Um,
uh, in the
check.
settings of here or the in the settings of Zoom or
Within the settings of the operating system.
okay. Yeah, I usually use these Teams for the
How about you stop sharing and we'll hear from Lorenzo. And in the meantime, I think if you explore your settings, you should be fine.
uh, okay.
Can you see my screen?
Oh, yes,
Yeah.
yes, I can see your screen. Yeah,
Okay.
everything looks fine.
Sorry for
Yeah,
the
okay,
interruption, but I tried technically.
no
Okay.
problem. So over to Lorenzo.
Okay. So thank you so much again, Nick, and the whole Flower community for this opportunity. So I'm gonna talk about our interaction between federated learning and robotics, and specifically the ROS framework. Let me say just something about me really quick and the research group. So I'm currently an assistant professor in the University of Messina. I work at the cross of distributed systems and artificial intelligence, and my research has really application in many fields like smart city, healthcare, natural disasters, and so on. So Messina is really in the heart of the Mediterranean. So we have it's the piece of the land on the left, and we have also the opportunity there to have different applications for our use cases. And this is part of the group in a funny moment. And we are a lot, and we're a lot also because we have the opportunity to have different projects going on. This is just a selection of the most important projects we have right now, a research project like the European one. And let me just focus on the TEMA one because the presentation that I'm doing comes out from some idea that is from this project. TEMA is about natural disaster management. Specifically, the University of Messina is working on providing distributed artificial intelligence for running artificial intelligence applications, but also for improving the orchestration and offloading. So federated learning is there inside for these two reasons, let's say. Then, I mean, the reason that I'm discussing today is mostly an application reason for robotics. This is the normal contents that we typically have. The introduction is about federated learning. I will not discuss it. I think we are on the same page. But what is really important now, and I will focus from my own, is to discuss about federated learning in robotics and what is the research trend. If we look on Scopus, is one of the most important database for paper. we can see that the first paper is of 2018, and there are not so many papers, 123, but the trend is growing a lot. So in the 2023, there were really so many papers, so it's exponential, the behavior right now. We read some paper about it, and we are, I mean, we know enough about the utilization. Most of robots application today are about drones, mostly for military, but also civil applications. And federated learning is used for the optimization, sometimes for resource allocation, sometimes for communication. There is really some problem with robotics. The first one is that even if there are many frameworks about federated learning, and Flower is one of these, one of the best, still this really doesn't work if we want to maintain real ROS communication. What is ROS? ROS is the software that roboticians typically use. Is the robot operating system. It's not really an operating system like we know, like Ubuntu, Windows, and so on, but it's mostly a middleware to interact between the hardware and the high-level services. ROS2 uses an internal communication system. It's called a data distribution service. And that's why our idea was to somehow starting from scratch a federated learning framework for ROS. We call it FedROS just to give a name to this one. It's anyway a good name in this case. And this enabled the possibility to have the learning jobs on ROS devices, so drones, rovers, humanoid robot, and so on. The other thing, and we will see why, is that we needed a way to create federated learning jobs. And so we thought, and our distributed system background come out in this case, we created a kind of platform as a service for creating federated learning jobs. So that's the methodology, and this is also something that we in part already shared with the Flower community in the Flower AR Summit this year. The idea is this one, to have different inputs, are the common inputs that we have in AI projects. So of course the data set, the creation of a model, loss function, optimization function, and then all the hyperparameters in a configuration file, battery, input, output sites, epochs, momentum, and all the other hyperparameters that are needed. In the middle, we see the ROS components. ROS is built in using ROS packages. Inside the ROS packages, there are multiple ROS nodes. Each ROS node should be dedicated for a specific application. Typically, one ROS node could be to move to use the model of a well or to sample some data. In this case, we created some ROS node for the training on the client, and some ROS node for aggregation in the learning in the federated learning server. Of course, the client one is not just one block, but is multiple blocks. We have, of course, multiple clients. What you see written there is the normal algorithm of federated learning. In the output, we have the global model weights when we need to make the aggregation, or just the model when we are ready for the prediction. Let's see how we create the job. So what is the process for creating the federated learning job? So first of all, we create a manifest. It's a YAML manifest. So the FedROS user implements the model. We will see some example, the optimizer, the loss function, and so on, by extending abstract classes. On the right, we can see an example of federated learning job creator manifest. We have the strategy. I don't know if you can see the mouse. We have the strategy here to select the number of clients, other parameters for federated learning, like the number of rounds, then model, optimizer, and so on. Also data, where they are, other parameters about data. Let's get an insight on each of them. So the model needs to be built using a standard class. What does it mean? We need a specific model, a specific name for the class, and a specific name for attributes and methods. Why? Because given that we are injecting from the external world the models and loss function, optimization function, and so on, really the application that will assemble all these components doesn't have idea what is inside the model. But this application knows that there is the model class, there is the forward class, and we will use it. So we are trying to really abstract to an high level position the entire components. This one will be stored ideally in a task repository. For testing purpose, it's just the file system. Loss function is like this, so maybe it's much more clear what is the logic of the creation of these classes. Loss function is always the name of the class. Then I used the builder pattern here. I prefer it just for to be more clear in the implementation. In the builder pattern, you can see the creation, in this case, of a cross entropy loss, which is called the loss function, and we get this loss function with a get method. Same stories for the optimizer. You can see here more methods because they were important for building the loss function. And then we have here an example of configuration files. So it's a YAML or a JSON file where there are, the hyperparameters needed for the application side, but we have also some information which is important for ROS. This is something that we are going to move in a, let's say, default configuration file, a system configuration file, so the user cannot modify it, cannot really change the behavior system. What is at the end the goal of having all these different files? Is assembling the client. Why we have to assemble the client? Because we will see ROS needs to be built. This is the most pain point that we have with ROS. Building means that we need to know everything a priori, and we need to build all these classes, in a building phase. We created then two different nodes, in this case, the training node for the client and the interface node. The interface is important because when a ROS node communicates with other ROS nodes, does it using a specific message, and this message is reported inside this interface file. We will see some example. I just give here some introduction. So the point is copying the file in the destination path. So we copy the model inside the training, the loss function inside the training, and all the other components. In this way, we build the ROS package, and we put everything in a Docker container for an easy deployment. This is, some piece of code from a Docker file, dependencies for ROS, and we can see here the building phase. So the Colcon is an application that ROS use, and then we have the running. So at the end of the system, at the end of the building, we can run the application. It seems in some way easy described like this, but we have two main issues. Because the design seems fine, but when we move to the implementation, we have to consider two things. The first one is that, as I said, the ROS needs to be built in runtime. So that means if we want to have something dynamic, parameterized, something that following all the object-oriented programming needs to be reused in the future, we should need, we should rebuild applications many times, and we should build an application for each kind of neural network we want to implement. So that's why we should know a priori what is the application, but really in our case, we don't know a priori what is inside the manifest. So we need to create some kind of application that is able to abstract this process. The second problem is the communication problem, as I announced already. So ROS uses this DDS communication publish subscribe. The interface message should be defined a priori before the building phase. But this is like saying that we know what are the weights matrices, but we don't have any information about the model. So this is something that we cannot do. This is an example just to give you an idea about what is a message in ROS. These are two different messages. The first one is this one, where we have to define the type of the variable and the name of the variable. Then there are here other kind of messages. You can see this X is a float 64, while this sequence is a unit 32, stamp is a timestamp, string, and so on. Why this? During the building phase, this file, which is just a text file, is translated in a C++ class, and each of these variable is accessed with the dot notation. So it's really complicated. It was really a mess to try to build this kind of file for all the neural networks that we create. So what is the solution that we imaged? So the first one is to make a composition, the composition of the training and the aggregating. Of course, when we make the composition of the first training for the federated learning client is the same for all the clients except for the dataset, of course, which will be different. When we talk about the aggregating for the server, it's of course just one single instance, and that's fine that we create this. When we talk about the interface, even in this case, we want to create the interface message in runtime. How? Extracting the information about the weights in runtime. So that means we need to load the model. We need to read inside the model all the type, all the layer shape, the number of parameters, and we have to do it before of the building phase. This is an example of interface message if we have a convolutional neural network, just a simple one, and this is programmatically written, okay? This file is not written by a human, but is written by a program. And we can see that we extracted that this is an array in float 64, and this is the name of the layer. And we have, the information for all the layers. I have really a quick demo that can help to understand what we are doing. I will jump on the important moments. You can see here on the left, the file system. We have the Federos client and the Federos server. These two packages are not self-sufficient, as I said. We need to inject the model, loss function, configuration file, and so on. So when we run this script, and the manifest was the one that we saw at the beginning, you can see now on the left that everything is copied. We have now the loss function, the models, the optimizer, and we have on the Federos server side the config, and inside the node folder we have the aggregation algorithm. So there is a moment when the Docker containers are created and the application are built. As soon as we don't need anymore the files, we just clean it up. So we don't need to dirty them in the system, but they are already built inside the application, inside the Docker container. The Docker container is now building the ROS nodes, the interface, the training, and also the aggregating. Let me jump now here where the training already started. We have just 5 rounds and 5 epochs. We can see that the system is learning, reducing the loss and increasing the accuracy. I just jump at the end, and we can see that it's working after 5 rounds. This is not just to see how the training is going, but to see that the system is working. Let's see now some result. And I have some result where the testbed was just a MacBook Pro M3, so last generation. And we have results both from the composability, so the assembly of the system, then also from the federated learning point of view. About the assembly performances, we try to focus on the most important and most, the part that needs much more effort. This is about the get model architecture. In this moment, we before the building, we access the model, and we try to read from the model programmatically the number of the layers, the name of the layers, number of parameters, and the shape. And this is important to write the interface file. we really tested the system. In robotic, it's a bit complicated to have something like 10,000 of clients. And even if we have 100 clients, if they are drones that are running in the same area, this is really complicated to have 100 drones. But we can see that the system is, for this kind of numbers, really working good. So we were able to have in 1 second 100 clients that were built. And if we just increase, it's still done in 4 seconds or less than 5 seconds, 10,000 of clients. When we come to the creation of the interface, it's just an input-output operation. We have to write this message file. This is done really in a short time. It's 0.005 seconds or more or less, but when we increase the number of clients, it's just 0.01, more or less. And this is about the creation of a deployment manifest that we did just for testing purpose. Of course, when we move in production, let's say, we cannot work, of course, in a single machine, but we have to redistribute to different machines, so different drones, different robots. But in this case, for just creating this file, at the end of the day, the process will be still to create a file, but with the remote connections. We have input-output operation that grows more or less linearly, something exponentially, but it's in the order of 2 seconds for 10,000 of clients. One of the big issues that we have is the size of the container. The ROS container alone, Iron is one of the last versions of ROS, is already 700 megabytes. When we install the dependencies, we just increase not so much, but then when we install also the Python free application dependencies, not only the ROS one, but also the application one like PyTorch, we use it PyTorch, and also the application, it grows up to 1.5 giga, more or less. So it's not really an issue to have 1.5 gigabyte in a drone or in a robot. Okay, of course we have space. The issue could be in distributing this kind of application, because we need a time to download the whole application, so to pull the container, and the provisioning, the deployment could be something that we need to take care about. Then we have some tests on the federated learning side. So we run one model, convolutional neural network with the layers you can see on the left. And we use the standard MNIST. In this case is IED sample dataset. We have for the federated learning the training set with 2000 of images and the test set with 333 images. With the benchmark, we just summed all of them because we have 3 different clients. We have 6,000 and 1,000 of images for the test. What is the goal for this kind of test? The goal is understanding if the federated learning approach for robotic is working. So we want to equalize the accuracy of the proposed approach, the FEDROS, with a traditional approach. So we want to overlap the curves of loss and accuracy. But at the same time, we want to see an improvement in the computation time, because we are parallelizing the computation. It's not done in one device anymore, but it's done in multiple devices at the same time. So we want to see some better result in this case. So we used 3 different Raspberry Pi clients, so microprocessors. We really underestimated the system, because typically a robot can have also some device which is a bit better. For instance, some NVIDIA Xavier or NVIDIA Orin, so with some mini GPU inside. We can see for the training dataset that the loss and the accuracy for the federated approach and the traditional approach is overlapped, so we have a good behavior of the system. The same we can say for the test. Of course, we have a bit more fluctuation, but the system is working quite good. And we can say also that we have an improvement in terms of computation time. So if we run the traditional approach on a Raspberry, we get more than 1 hour. if we run on 3 different Raspberry using the federated average algorithm, we really decrease of more or less 50 minutes. Okay, so we have the application in 23 minutes using a Raspberry. And we can really also reduce the number of epochs because the 95% of the accuracy was reached in 50 epochs. So that means we can have also a time which is minor. Let me go to the conclusion, just to say that we try to fill a gap that we encountered right now in the literature, in the state of the art. So a way to have federated learning in robotics using robotics software systems. Okay, it facilitates the submission in this case of federated learning jobs. We have still a lot of work to do in this case, but the first demo, the minimum viable product, let me say, is quite usable. In the near future, we want to do these kind of things. First of all, testing with different networks. Okay, one of the issue we have right now, I mean, it's not really an issue, but we just tested with all this convolution neural network. We want to test with different kind of models and different kind of data sets, both ID and non-ID, to see what happens. ROS has also a different paradigm other than the publish subscribe. There is the client service communication, is more an asynchronous approach, which is much faster, so we can maybe get an advantage. And the other thing is simulating on a real distributed environment, so could be a swarm of drones. The other point is trying to understand if we can really use a framework that has a good community on the back, like Flower. I mean, we don't want really to reinvent the well. I mean, we had the need to program from scratch because there was nothing that used the ROS publish subscribe communication system, but could be really important to be, I mean, in the game of the federated learning that today everybody's playing, and then using some framework that already exist. Because the possibility was with Flower at the beginning, and I mean, we can maybe open a discussion, Nick, I mean, the other guys, that we can discuss now or offline, that we can use ROS also with normal HTTP communication. If I remember well, Flower used gRPC or something like this. But we are not using really the ROS communication. So we should understand what is really important also for roboticians and what could be better for robotics in general in this case. So this could be something in the future. Why I'm talking often about drones? Because on the European project, we have the possibility to talk with end users, so to make some experiment. In natural disaster, drones are often used to look into the disaster, typically later the disaster, after the disaster, looking for objects, looking for humans, looking for cars, buildings, other kind of stuff with pictures and drones. Federated learning and drones is an interesting match. We thought at the beginning that we could try to have any kind of algorithm inside, but maybe supervised learning is a bit complex because that means that while the drone is flying, we should also label the new samples. And this is something that technically is doable, but seems unrealistic. So we are exploring also some unsupervised approach in this case. So this is all. Thank you for to the audience for being here. This is a bit of bibliography about the presentation, and now I'm open to any question.
Thank you so much. Very interesting work. Let's see if there's any questions either on Slack or for people who are here locally. Yeah, if there's any questions, we can take them. Let me take a look in Slack in particular. Yeah, I guess one question, I think you were answering this, although I also didn't seem to hear a sort of a clear answer on it, which was when do you think we could actually use this on a piece of on a drone, for example, on a robot? The question was saying when do we anticipate seeing this deployed onto a robot of some kind?
Yeah, there are different. I mean, let me say, it's not really easy. We are discussing also with the robotics community for this reason. Robotics community sometimes has also some issue in terms of distributed systems, but is really good in AI. So we are trying to make a match in this case. One point is, and it's something that we have to really validate. So the drone, of course, when is there for the natural disaster, needs to be up and running. So the model needs to be there immediately. We cannot wait that the federal learning start from scratch a training and a model. So that means there is already a pre-trained model that is doing its job, which is recognizing people, humans, objects, and so on. But at the same time, we can fine tune this model with the geography of the land, new pictures, the specific disaster, and so on. So this is something that we can do at the same time. So there is a thread that is doing the prediction, a thread that is doing the sample, and at the same time, this sample is trained in a federated learning approach. So this is something that we want to try. It's really challenging because the drone is probably the most complicated element in this case for robotics and federated learning, because the drone is battery powered and the drone in average flies for 20 minutes. So we don't have really so much time. So we are trying to understand if we can do everything in less than 20 minutes. Then the drone needs to be back to the base station and to recharge. The base station is, in our case, also the aggregator. So if you fly like free drones, there is a base station, which is a laptop, a computer on the field that collects your data and is used to control it. And also from the regulation point of view, because from the regulation point of view, during a disaster, a drone cannot fly, at least in Italy where I live, but in Europe, more or less, it's like this. That means it shouldn't, and also cannot be autonomous. It's really dangerous right now. So we are really looking ahead in this case. It's really a research approach. So we are looking what we can do, understanding if using this kind of device could be safe for humans and for first responders, so civil protection, firefighters that are there to help. They don't need to be distracted by this kind of stuff. Today, having, of course, one person per drone is not scalable. Because currently, if you have 100 drones, we need 100 people. I mean, it's not doable. That's clear. So this is one of the cases that we are investigating because we have, I mean, a project here. But I see also good application in social robotics, industrial robotics, where, I mean, the situation, let's say, it's a bit more easy. We are not in a disaster. We don't need to have sometimes, mostly in social robotics, a real-time decision. I mean, we can do it with a bit most of relax, let's say. So there are cases where this application is less constrained. And this approach is good for any kind of device that can install ROS. Okay, so drone is one example, but there are many of these.
I see, I see. Yeah, we actually there's a few more questions there, but we've ran a little bit over time. So yeah, thank you for the talk. It's really interesting, and I really look forward to tracking how this goes and where it sort of heads to next. I think there's also a lot of interest in the community for this. You mentioned a lot of people using ROS for a variety of reasons, I think on some certain embedded systems and so forth. So this capability I think will be warmly received. Yeah, so thank you again. Thanks so much.
Yeah, thank you so much.
We are now going to hear from Samena Mohammadi of RISE. This is the Research Institutes of Sweden. We had a little technical difficulty before, but I think we've got it all ironed out. And so I'm delighted to have her with us to talk about scalable functional encryption within the context of federated learning.
Hello, everyone. Sorry for the technical issue. My name is Samane. I'm industrial PhD student at RISE, Research Institute of Sweden. So today I'm going to talk about our recent work, which was a joint work with Vasilis, who is a PhD candidate at Eindhoven University. So this work was like a joint collaboration throughout this project. So our recent work called N-cluster, which means that scalable functional encryption in federated learning. I just skipped this introduction to federated learning, but from the privacy point of view, federated learning can preserve the data on a local devices and can minimize the data exposure to the outside of the system. If we compare it with machine learning, it's enhance and preserve the initial level of privacy, and also support to regulatory compliance such as GDPR and AI Act, and minimize the leaving and minimize the data exposure to the outside the system. But when it's come to sharing this model parameter with outside, there is a possibility of leaking sensitive information of the user, of the training data set of the user. Malicious client inside of the system and outside of the system, by having a different level of access to the model parameter or architecture of the neural network or different type of parameter during the training round, and can conduct different type of attacks such as model inversion attack, membership inference attack, and property inference attack. And by accessing this type of the model parameters such as weight and gradient, can reconstruct and access some sensitive information. So let's look at this example that I captured from the mentioned paper, which is about the deep leakage from the gradient. So this example shows that how gradient inversion attack can be pose a significant sharing this model parameter during the federated learning can pose a significant privacy leakage during a training round. So the aim of this attack is reconstruct or infer some sensitive data from share gradient or model parameter. And this image, the top on the left show the original image, and another image show that the attacker tried to reconstruct this image from the shared gradient of the client. So as we move to a row of the image by moving forward and in each iteration, the attacker can improve and make it like a clear image, and exactly at iteration 218, it's exactly look like the same image as it's used for the training. So this show that how the sharing and exchanging model parameter between the client and server can pose a significant privacy leakage during the training round. So to preserve the privacy in federated learning, we need to apply additional privacy preserving mechanism together to federated learning to prevent this kind of the leakage and any threat from the entities from the client, server, or outside of the system, and preserve the privacy. So some of the common one is using an encryption-based approach, especially in homomorphic encryption and functional encryption method. So let's look at these two methods in more details. So homomorphic encryption is a form of encryption that enable performing computation on encrypted data without decrypting it, which means that the client encrypt their model parameter and share it to the server, and the server, without having access to this encrypted model parameter and decrypting, can do aggregation on the encrypted model parameter without accessing to this original or model parameter of the client. So it provides the individual level of the privacy that the client model are hidden from the server, and provide also secure aggregation and also communication. So even the eavesdropper cannot access to this access to the encrypted model parameter without having the private key. But the main problem is here is it leads to high computational cost on the client side, which in federated learning scenario, it's mostly like involving resource constraint devices, and it make it the training round slowing, like a slower training round, and overhead in the whole system. And another thing is the problem in homomorphic encryption is that system is vulnerable to malicious client, which means that all of the client have the same private key, and if the client share this private key with server or outside the system, it can easily like decrypt this model parameter. So in the homomorphic encryption, the system is still vulnerable to malicious client. If some of the clients acts as a dishonest or malicious behavior and share this key with the outside, it's still possibility to leakage of the privacy and security in the system. While functional encryption can improve and can defend this kind of the attack and like a leakage in a system, by providing a specific computation on encrypted data and controlling what kind of the data can be decrypted. So this means that the only result of function can be like a reveal rather than the whole individual model parameter. So let's look at when it's applied in federated learning. Consider that the client encrypt their model parameter and share it to the server. And so the server can just decrypt this aggregation by using the decryption, functional decryption key, can just access to the output of the result of the aggregation model parameter, and without and cannot access to the individual model update. And so and also the client have their own encryption and decryption key. So each of the client create their own partial decryption key. And in this case, if also someone share their own decryption key, it's not possible to access to other client and cannot access to decrypting this model parameter of each client. So in this case, the individual client updates are hidden even from the other clients, and all of the client, they have their own private encryption and partial decryption key, and it's not shared between the client. And also this kind of system, decentralized functional encryption, provide the target privacy and control on the whole encryption and decryption process. But still, it's have some challenge when it's applied in federated learning. It's really complex to key management part, because it's needed to have a trusted third party to generate the whole key for the encryption and decryption and share it with client. And also it's applied the high computational cost on the client side. And still in a federated learning scenario, we have a resource constraint devices. And another problem is that we need to mostly this kind of the method mostly rely on fully trusted third party, which means that if this third party authority comprised, so it's make it like a system, the whole system can be under risk for the privacy and security. So what we see here, when we apply a cryptographic protocol in federated learning scenario, we can see a secure federated learning dilemma, which if we want to have a higher privacy level in a system, it costs to sacrifice the efficiency in terms of computation and communication, and in some cases effect on the model performance. So to avoid this kind of a balancing, to have some balancing privacy and performance, we need to propose efficient and scalable cryptography solution when we want to apply in federated learning scenario. Because in this case, we need to make it more, because in federated learning scenario, we have this is a decentralized and clients have a decentralized nature. And we need to have a scalable, because the client can be a lot of client can be involved in a system, and also make it more efficient without adding more cost in terms of communication and computation to the system. So also by looking at the literature review and related work, we can see that most of the related work that use the encryption, homomorphic encryption, and functional encryption method mostly rely on fully trusted third party that generate their key for like a encryption and decryption. And also, they don't consider the efficiency when it's apply on federated learning scenario. So it's make it very high cost in terms of like a communication and computation. To solve this problem, our work mainly focus on eliminating the need to fully trust a third party in a system and make this encryption method more efficient and scalable. When we apply it to federated learning, it can be like a practical for resource constrained edge devices. So we propose a method in cluster, which means that scalable functional encryption in federated learning. And our framework consists of 3 building blocks: model comparison method throughout weight clustering, functional encryption method, and also binary fuse filter. So I will look at let's look at it more like a closer to the client side. So in the client side, we do this local training as usual, and then apply the weight comparison method throughout weight clustering. So this weight clustering is cluster the similar weight into the similar weight by using the k-means. And then after we apply this weight clustering, we will have a 2 array. The one array can have a centroid of each cluster, and then the another array show the cluster weight mapping, which associate to the each of the weight assigned to the which of the cluster index. So then on the client side, after having this weight clustering, we apply the functional encryption on the just centroid of the each weight, and this is really smaller than the whole weight of the each client. And we just need to have the third party authority, and we don't need to fully trust it on this party, because we just apply this functional encryption on a centroid. And this party, without accessing to this weighting matrix, it's not possible to recreate or generate the weight of each client. So then for the like a weight mapping matrix, we apply the binary fuse filter that hash this. Binary fuse filter is a probabilistic space efficient probabilistic data structure that map the data to some fixed speed, and also compute also compact the data by using a hash function, and then create a fingerprint array. So for doing this and creating a fingerprint array for each position matrix, we need to seed value for each client. So this seed value is just shared between the client and server, and the third party authority cannot access to the seed value. So this is the main and key point of our method, that why we can remove the fully trusted third party in our method. And then on a server side, server get this encrypted centroid and fingerprint array from all clients, and then recreate the position matrix of each centroid, because the server has the seed value for each client by using this inserting this fingerprint array to like a hash function that we use, and by using this secret and unique seed value for each client, it generates and recreate the position matrix of each centroid, and then form the client encrypted weight by replacing the index of the index with the encrypted centroid value, and then server combine all the partial decryption key to derive the functional decryption key for aggregation, and just access to the aggregated weight without accessing to individual model parameter of the client. So this is the whole of our framework. So the key efficiency point of our method is that we apply this functional encryption key functional encryption method just on the centroid of each cluster without applying it on the whole weight of the client, and also apply this efficient encoding of the position matrix of each centroid by using a binary fuse filter. And in terms of the privacy, and as we say that we remove this fully trusted third party in our method, which means that the server can reconstruct the position matrix, but still cannot determine the client weight based on this centroid. So this, if the server acts as a malicious party, just it can access to the like a weighting the position matrix of each centroid, and the third party authority can access to this centroid of each weight matrix, but cannot access to the position matrix of each weight. So it still cannot reconstruct the client weight of each individual client weight. So for the privacy analysis, we consider different type of threat model in our system, and to show how our method can defend against this kind of privacy leakage. So the threat model that we consider is honest but curious server, which means that the server can follow the a whole protocol, but still have some a curiosity about the model parameter of the client. And honest but curious also third-party authority that still follow the whole protocol, but still have some curiosity about the client model parameter. And this honest client, which means that the client can collude with the server to get model parameter of the another client. And we provide some analysis mathematically or a proof based on that. We assume that if we have an isolation or reply attack from the server side, how our system can defend against this type of attack, or if the server or client try to reconstruct some model parameter in the system, and also if we have a comprised trusted third party. So we provide this kind of analysis in a paper. I'm not go to in the details. If you're interested, you can check the paper analysis regarding the privacy and security analysis. So for the efficiency evaluation part, we consider the CFAR10 and 100 as a data set, and also we have 4 models to evaluate our method. And metrics, we use the accuracy loss compared to Fed average, data transmitted, the volume of data transmitted compared to the Fed average, and also encryption time measured by a second. And the baseline, we consider the Fed average with applying the weight clustering, CFL method that use the homomorphic encryption with gradient pruning technique, which is one of our previous method, and DTrustFL that combine the functional encryption with global differential privacy. So we compare our method with 4 baseline. Let's look at more on the performance. So for performance analysis, we consider different type of federated setting, IID or non-IIDness of the data, and considering different a portion of participation from the client side, and on a different type of data set that we have. So if we want to just have some example, for example, if we want to compare it our method with DTrustFL that use a functional encryption, we make the data transmitted between the client and server 30 times less than this method, and encryption time 160 faster than the DTrustFL method. And just comparing our method with the homomorphic encryption CFL method, we make it 9 times less for the data transmission and 4 times faster for the encryption part. And also, as this method use the gradient pruning technique, so it's effective the accuracy. So we just compare our accuracy loss with this method. So as you can see from this this part, we preserve the accuracy loss near to 1 to 2, but this CFL method is like a privacy loss is near to 2 until like 4%. So we also have computational, in terms of computational efficiency, we show that by having a different key size in a encryption-based method, you trust CFL and OR method by using a binary fuse filter and without using a binary fuse filter. And this show that increasing the key size and execution time that takes for the encryption. As we expected, by having a larger key size, we require more computational resource and execution time. But take a look at the example on a Bitcoin key size, which is near to 256. Generally, they use this key size. So for our method, by having a binary fuse filter and not having a binary fuse filter in a blue chart, for the execution time, it takes just 2 seconds. But if it's come to dtrust FL, it's take 329, and for a CFL method, it's 7 seconds. And for the computation efficiency, we still have the different key size and data transmitted by comparing to Fed average. So our methods show that we have a more consistently data transmission amount by increasing the key size, which indicate that we have like a really efficient and scalable method when it's applied and having a larger key size. So by having the same example for Bitcoin, Bitcoin key size, we for the data transmission, if we have by having a binary fuse filter, we have a 1.2, and without having it, it's sorry, by having a binary fuse filter, it's 9.2, and by without having it, it's 1.2 times by Fed average. While this amount is for dtrust is near to 120 times of Fed average, and also for CFL it's 80 times to Fed average. So it takes like the data transmission volume by comparing when we just share this model parameter using a Fed average. So we also have some evaluation regarding the scalability of the our method. By using a different type of cluster size and also different type of key size and showing this having a different number of cluster, how it's affect to accuracy loss, and also different type of key size and data volume that share like during the training round. So, for example, in a figure B, we show that by increasing the cluster number, we reduce the accuracy loss, which is as we expected, because when we increase the number of cluster, it so the weight is not too much like the weight can be like maintain as a similar to the like a previous one without having or rounding it. And for the and the figure A show that the impact of cluster size and also different number of key size. And our method show that by increasing the security level and the key size, we have a slightly effect on the data volume that's shared between the client and server, which is really slightly from the 0.2 till 0.3 across the old key size, which show that this method really scalable on the different level of the key size when we increase the security level. And we have also analysis on different type of model, neural architecture. And we want to show it the generalization and scalability of our method across the different model architecture by showing it the accuracy loss and encryption time. So we show the slightly our method show minimal accuracy loss across all the architecture, neural architecture and data sets, and even by having a larger model like MobileNet, we have a less impact on the accuracy loss compared to a smaller model. So as a conclusion and key takeaway, we propose and combine three building blocks: model comparison, decentralized functional encryption, and binary speed filter to encoding and we ensure the privacy preserving without compromising the efficiency in federated learning. And we in terms of communication and computation gain, we have a reduction near to 30 times, and in terms of communication costs, and 160 times speed of the computation by comparing to a relevant work and baseline. So we design a private and efficient federated learning paradigm, and which can be applied on a resource constrained edge devices. As a future direction, we want to advance the functional encryption method, which can eliminate the third-party authority from the whole system. And additionally, we want to take a look at adaptive weight clustering that dynamically adjusts the cluster size based on the model and task a requirement to make it more dynamic and based on the each architecture. Thank you for your listening. So here is our email. If you want to if you have any question, please reach out. And this is a barcode for GitHub and archive of our paper. So
Thank you so much. Really interesting work. We're a little bit short on time, so I'll just ask one quick question, and that was, how would you, if you're a user out there, you're trying to build a federated system, these issues are a concern to you, and so you're looking at various options. What would be the scenario in which you would go for this solution? You know, sometimes people might pick homomorphic encryption. Sometimes they might pick differential privacy, perhaps. Depends on what the attack concern they have is. And so many of these are fairly well known. I guess the three most popular would be FHE or HE, homomorphic encryption, differential privacy, secure aggregation. They're the most three popular ones. I assume people who want to be resistant against these sort of privacy attacks that are building on top of federated but basic federated. And so could you just briefly 2 or 3 lines explain what is the kind of necessary conditions that somebody would say, okay, I've got these conditions, so I'm going to jump and use the method that you've presented very eloquently here.
Yeah. Thank you for a nice question. So I also I had a paper on differential privacy and homomorphic encryption, and what I see in different a method that I apply on different application. So differential privacy effect on the model performance, and it's sacrifice the accuracy of the model. But this method doesn't apply too much a burden in terms of communication and computation costs. It's really simple and it's really easy to apply on federated learning scenario. I think in a case that the accuracy is if any case, and this differential privacy also cannot provide a strong level of the privacy because it's add the noises to the model parameter, and it's still vulnerable to different type of attacks, such gradient inversion attack that we saw in in mentioned in a previous slide. So if we need to have some slightly a privacy method, we can apply this differential privacy, but we need to have some balance between the privacy and accuracy level. So if our application need to have some accurate result, we need to have a adaptive noises to the model parameter, and make sure that what is the best level of the noises to model parameter in terms of their a system requirement. But when it's come to like a more sensitive data set, like healthcare system or financial like a data set which is really sensitive and related to like a user data set or relieve some identity of the user, I think it's needed to provide really like a strong privacy to avoid and mitigate any privacy leakage in federated learning. So recently I joined to the project that they are mainly working on the healthcare system and psychiatric problem. That's mainly like using the like a patient data set to provide like a diagnosing using this type of the data of medical data set, and they are suggesting to use the encryption method because they really care about this privacy and security of their data set, and they can provide a system that can provide higher computational a resource for the devices, and they want to just want to have a strong level of the privacy, and they can provide the communication or computational cost, and in this case we can easily deploy this encryption based method in the system. So if I just want to say it, it's totally depend on the application requirement, and before going further for the privacy or security method, we need to know what is the exactly requirement of our application. Do we need to care about the accuracy or performance? Can we provide a strong can we have a resource enough resource to deploy encryption based method in the federated learning?
I see. Makes sense. Makes sense. Awesome. Yeah, well, this is a critical issue for the community. Many people are thinking about this on a daily basis, given the type of data they're working with. And so, yeah, thank you so much for sharing your innovations. Very interesting stuff.
Thank you.
We're pretty much out of time. So I'm going to share the slides and then basically wrap things up for us. Um, this has been Flower Monthly for September. We had two amazing external speakers here. We had Samantha, who spoke about this encryption techniques to help you protect your data. It's been collaborative work, but she really explained to us some key details. But we also had Lorenzo telling us about how you can use FL with Ross, and then the kind of the applications are really pretty powerful in that direction too. So I want to say thank you both of them for the time they had to share with us today, and you can join us again October the 2nd. We'll be at the same time, and we'll have another two speakers from the community sharing with you what they have been building with Flower. So again, thank you everyone for joining us today, and have a good rest of your week. Take care.
Thank you for inviting us. That was really pleasure to us here.
Great, great. Bye-bye.
Bye.
Bye.